Hey guys, and welcome to today's session. We are going to be talking about creating scalable and resistant systems architecture. My name is Liz. You'll hear all about me and my journey in a few slides, but I first wanted to start by welcoming everyone to either the live Transform conference or to the live replay if you're watching this on YouTube. Software Underground is an incredible organization, and if you are not familiar with their work they are doing, please go ahead and check it out. Whenever anyone approaches me who's a geologist or geophysicist and wants to learn more about becoming a data scientist, this is your best first bet to check out. All right. So as we go ahead and move forward today, here is our agenda. So we have 3 hours planned ahead of us. I have 2 breaks planned in here, but this is meant to be somewhat unstructured. All Q&A, as a heads up, should be directed to the Slack, the hashtag T20 Thursday SYS. That is a live Slack. There's a little bit of delay, but we will be using that to ask questions, to get responses. And if you have anything you want to contribute, feel free to ping that there. From a high level, though, here's the agenda. Part 1 is working backwards. We're going to talk about user stories, and we're going to talk about translating business and technical requirements. Part 2 is going to delve into services, solutions, and scalability. Now, if you are a power user with AWS and you can build and whiteboard beautiful architectures, this probably will be great review. If you've never actually logged into the AWS console, I'm going to show you some tips and tricks to go ahead and get started and give you some insights to places you can learn more. From there, we're going to talk about whiteboarding as a superpower. Now, if this session was together in person, there'd be a big, beautiful whiteboard behind me, and we'd go through doing some things together. Since it's a virtual format, I'm going to share my tips and tricks for virtual and online whiteboarding. We'll then take a break and then talk about the AWS well-architected framework, what it is, how you can use it, and how you can drive user and business requirements with that framework. And then finally, we're going to wrap up. We're going to take all these pieces that we've talked about and we're going to bring them together so that instead of just having good ideas, you can put together a comprehensive plan. Again, feel free to direct all your Q&A to the Slack that I pinned below and that should be live throughout this. All right, so even starting from a working backwards approach, we'll go into more about that, what that means. But throughout the next 3 hours, I have a few key learning objectives. First off, I want everyone to understand the basics of translating business requirements to technical requirements. Secondly, knowledge about key AWS services and where you can go to learn more. Next up, I want you to have 2 or 3 techniques for whiteboarding successfully. I want you to know about the AWS well-architected framework, how to use it, and finally, how to take all of these ideas and put together an actionable plan. Huge disclaimer before we step through this. This session I've put together is designed to mimic the real world. All the scenarios and personas that we talk about are not based in any individual people. They're purely my imagination, probably because I've been spending way too long over the past few months playing D&D. But these scenarios are not based on any one particular person. And because of that, they are designed to mimic the real world, and there's not going to be a right answer. In fact, we're going to step through guidelines and framework, but what you're not going to leave here with is a one-size-fits-all approach to go ahead and be a solutions architect. Instead, thinking about the things in my life that have enabled me to solve problems, really think creatively, and combine a lot of my interdisciplinary skill sets, I took the best practices that I've been using since I started about 15 years ago, the first time I really had to put together a cohesive project in undergrad. And I'm going to present frameworks and ideas and ways that you can leverage your own skill set with some additional guidance. If you ever feel during this presentation that you really don't know what you're doing or that you're really outside your comfort zone and you're not sure what the answer is, that's by design. And in fact, primary literature for adult learners shows that A, you learn more from your failures than your successes. And so pushing yourself outside your comfort zone is actually good. And B, that being able to persevere over obstacles and figure out ways to solve your own problems is going to teach you more than just getting things to memorize. Last disclaimer, although I work for AWS, all opinions presented here are my own. As with everything in life, your mileage may vary and it likely will vary. All right, now let's go ahead and get started. So what you need for this session. First off, whiteboarding supplies. If you have a pen and paper or a notebook handy, use it. I'm going to encourage you to take notes, to jot down ideas, and to actually try to solve these problems. If you're not old school, liking the analog pen and paper like I do, you can use either PowerPoint on your computer, or you can use a whiteboard app such as awwapp.com. You can have access to the AWS console if you want. It's optional. And you need access to Slack for the Q&A. And please, please bring your sense of adventure. If you just want to sit back and passively soak up information, you can, but I guarantee this will be a lot more fun if you lean into it, you try to actually work with me to build and craft and make mistakes, and we roll up our sleeves and get this together. All right, you guys ready? So first off, who is this person talking to you? Who am I? Why am I here? Well, first off, my name is Liz. Welcome. I grew up in a small town in Alaska, the kind of place where you can't just drive to the store and buy a new bike part if your bike fixes, like a rural enough environment where you had to be scrappy and building things. And that really led the foundation of me being a builder, which is how I identify today. I did my undergrad at University of Alaska before going to Wisconsin-Madison, where I got both a master's and PhD in astrobiology. Yeah, I actually worked for NASA looking at how life evolved on early Earth and how that could be a proxy for life on extraterrestrial planets. Geology, microbiology, a lot of surficial biogeochemistry, very interdisciplinary project. Shout out to the Badgers though, because right now the two other transform sessions that are being run at the exact same time are by Ashley Russell and Joe Kington, both of whom I overlapped with in grad school. After finishing my PhD, I wasn't quite sure what to do, so I ended up getting recruited and going to work for Hess as a geologist. So I'm a geologist through and through. I love rocks. I did field camp in undergrad. And at Hess, I was able to work both unconventionals onshore in the Bakken in North Dakota, doing some projects there, as well as offshore in Gulf of Mexico and in Guyana exploration. Now, I mention all these assignments because if you're following the trend so far, we have this Alaska upbringing, we have this astrobiology, we have geology, and then I moved to California to work for a startup, Biota Technology, whose mission was to pioneer genomics in the energy space. At Biota, I served both as a senior scientist and a technology director, helping to grow teams that could build labs, extract DNA from rocks, and then couple those insights into actionable next steps for E&P operators. From there, I was recruited by AWS, where I am a senior partner solutions architect. That means I work with AWS partners, both technology partners, as well as consulting partners, to build and launch cloud-based solutions that really focus on the energy space, not just here, but 2 years from now and 5 years from now. And again, if you're wondering what all of these things have in common, this Alaska, this Wisconsin, this geology, this technology, the common theme throughout all of these is not actually technology. I don't have a degree in computer science, although I can write code. I can definitely build systems. I love rolling up my sleeves and trying. I'm not a software engineer. That's not my skill set. What I am is a builder and a solutions architect. I have 5 of my AWS certifications, including the AWS Solutions Architect Professional. And when thinking about the material to present today, I am going to talk about the universal themes that have crisscrossed throughout my life and throughout my roles that really help to ensure that even though you can maybe design and build these great systems, you can make sure those align with broader goals so that they can be very impactful and transformative to businesses. Also, in case you join me via LinkedIn, another thing that I am doing and a great place to learn more, connect with me on LinkedIn, but I've also been publishing a fair number of videos on LinkedIn. Everything from imposter syndrome, from my background, to tips and tricks for AWS certifications, but also deep dives into a bunch of different AWS services. In fact, I have these 3 dice right here, and every morning I roll them, whatever number comes up, that's the AWS service that I talk about, and I record a short video for LinkedIn about that. So feel free to follow me and get more of a broad cross-section of what some of these services are, which we will talk about later. All right, so that is me. Now I want to hear about you and the attendees. Go ahead and pop on over to that Slack. I want to know if you've ever whiteboarded out an architecture before. Are you a seasoned professional at this, or are you like, wait, what? What do I do? Conversely, have you ever used AWS before? And then anything else you're hoping to get out of today's session. I've mentioned the learning objectives, but if there's anything else, maybe even a good AWS pun or joke, I will try not to disappoint. All right, looks like the results are trickling in right now. Cool. All right, so time for the first chunk, working backwards. User stories to drive technical requirements. Now, over the next 60 minutes, I hope that you guys leave with an understanding of the basics of translating business requirements to technical requirements. Here we go. All right, I want you to meet your customer. This is the customer that we are going to be working with today, Unicorn Reservoir Characterization. Again, note this is a purely fictitious company, and any overlaps is purely coincidental. But URC, these are our customers. Now, what does URC do? Well, as a new solutions architect, which is the job you are stepping into today, you looked a little bit and you found that they are a brand new company that takes a magical tool. Again, it looks a lot like a unicorn horn that's put down on a rock. So that analysis of that tool on the rock gives a readout of the elemental composition of the rock, porosity and permeability from that sample, and then a URC score. Now that URC score is a measure of how much your rocks rock. Again, we don't really know what that means, but this is your customer, and we are going to be paired with URC, or Unicorn Reservoir Characterization. They are a company that has this very novel new tool that is able to do some really sweet insights about the subsurface. And you, attendee, watcher of this video, bet you didn't quite know what you were signing up for. You, as a new solutions architect, are tasked with designing scalable cloud-based architecture for URC's workflow. Even though this is your formal definition, it goes above and beyond that. It's your job to make sure that the URC team not just has that architecture, but they can translate that into actionable requirements. All right, you guys ready? I hope so, because this, again, if you brought your sense of adventure, this should be a lot of fun. So, what's the first thing you do as a solutions architect? You want to design a system. What is task number one? Well, step number one is to do your homework. What is this company? What are they doing? What's their mission? What are their values? And so I always like to spend, the piece of advice I got was do at least 3 clicks when researching anything. But I like to spend at least 5 or 10 clicks trying to see what a company is, see what you can find online, follow them on LinkedIn, get a sense of kind of what their culture is, what their drivers are. And so by doing that, this is what you have found online for URC. It is a transformative product. It is focused on driving data science outcomes to reservoir teams of all sizes. There is no existing architecture diagram for their solution online, which is probably useful because if we could Google it and find an architecture diagram, our work here might very well be done. I don't know, it depends what it looks like. What you did find again and again is this schematic that's at the bottom. This unicorn horn tool interfacing with the rock, delivering this URC score. And that URC score is delivering next generation insights, scalable reservoir characterization, and data-driven workflows. Now, this is typical to what you find with a lot of companies of all sizes. Is they may have a product, but when you go to dig deep and learn about how the information flows, there's typically not that much out there, which is great. But we've done our homework, we feel ready. All right, next step with URC, if we want to put together this plan and whiteboard, is to define our key stakeholders and make a plan to connect. When you're looking at building architectures that are resilient, very, very, very rarely does someone give you a piece of paper with the current architecture and a piece of paper with the end state and say, all right, build this. If they could, that would be great. But that's not the reality that I have observed in my time. Instead, unpacking what is needed for success is much more a series of conversations and a journey that you as a technician and a technologist take along with the stakeholders from a company. From URC, for example, our key stakeholders are a list of 5. There's a technology VP that runs the whole team. There's an operations manager, a developer, a data scientist, and a product manager. And the product manager is the single-threaded owner for all of this, who self-proclaimed eats, breathes, this is their entire life. So now that we know these are our 5 people here, if we want to build this architecture, let's go ahead and actually figure out what to do next. We have 5 people, and in order to be efficient, you happen to have one-on-ones set up with each of the individuals over the next few hours. You have back-to-back meetings planned, and you are going to step into a half-hour, hour slot with each of these individuals. That is your chance to define the business and technical requirements. So, what's your approach here? What are we going to say? Well, we have a variety of stakeholders that range from the actual hands-on keyboard, tactical stakeholders that are doing a lot of the work, such as the data scientist and the developer. And then we have people who are responsible for setting the roadmap of the technology and also looking ahead in what's coming and looking very far ahead into what the aspirational vision is. So how do you approach each of these? At the end of the day, we want to put together a plan to build some kind of architecture, but how do you go about that? Well, figure out what your approach is. What do you jump in and say? Do you say, tell me about your platform? Tell me about your business needs, or do you jump in and say, all right, guys, SQL or no SQL? There's only one right answer here. Do you say, do you have any S3 buckets that are open? Or do you try to start with a joke and say, dude, do you guys even DevOps? Fun fact, I have tried a lot of these approaches. They can all be somewhat successful, but typically there's not necessarily a one-size-fits-all approach. The best I've come up with is working backwards. This is a very Amazonian key. This is a crucial component of the Amazon.com and the AWS culture. And the idea is that working backwards doesn't start with where you're going. It isn't even driven by a hypothesis, like a lot of my own scientific inquiry has been. Instead, working backwards is a process where you flip it and you start with the end goal. Not just the end goal of, oh, we want a scalable system, but the end goal of this is what the customer experience will look like when you over-delight your customer. You can use that to really unpeel those layers and unpack it. Well, how will it over-delight our customer? How will the reservoir engineers or geologists using the URC platform, how will we delight them with insights? How will they be able to get those insights to drive change in the reservoir? How will that impact well spacing? And really, by starting with that end goal in mind and then slowly stepping it backwards, you can use that as a key framework to help unpack where you're going. I have found also that when you start to work with this type of framework, it can tell you so much more about who the people are, what their perspective is, and how the group works together than you ever imagined. I do want to note that for the sake of this demo, we set up individual one-on-one meetings with all these stakeholders. Another thing you could try is getting everyone in a room together and trying to figure out what working backwards is collaboratively. My experience has been that if you don't know any of these individuals, you don't know what the cultural norms are, and you don't know how they interact with each other, by having focused one-on-one conversations first, you can use that as a period of investigation. And you can figure out what some of the drivers are, how the pieces work together, and you can really take a step back to think tactically about how you can help to drive the best outcome. It may not always seem like it's the best use of your time, but investing time to get to know the people and what their vision is and how they all fit together can really make the process at the very end, when it comes time to execute, a lot smoother. All right, so we have a plan, we have a framework. Now it's all about defining the actual technical requirements. I've said this, I think, 17 times so far in the first 20 minutes of this talk. We need to define technical requirements. That seems really straightforward. You know, what do you need the system to do? But in reality, it typically is not that straightforward. In fact, the goal here is to define technical requirements that align with the business objectives. Yes, the technical requirements for this instrument could be process 100,000 samples a year. They could be ultra low latency access to the database. They could be access to Jupyter Science notebooks from anywhere. They could be automatic backups. These could all be the technical outcomes, but they don't align with the business objectives. And if we really are going to focus on a working backward process, looking at the business objectives, we need to be very clear that there's frequently a disconnect there, and what you hope to accomplish is different than how you accomplish it. So by very explicitly defining the business and the technical requirements, you can make sure there's really good alignment. Another thing to keep in mind is separate out the need to haves from the nice to have. As you'll see when we step through these conversations, some people are ready to boil the ocean. They think that if you are going to re-architect a solution, let's take it to the moon and beyond. Let's not just focus here. Let's make it as broad and impactful as we can. And that is a great energy to have, and that can be really helpful. But being very explicit with here's the initial scope, here are the needs to have, and here are the nice to haves, nices to haves, that can help make sure that you can deliver and get enough internal momentum that people can be aligned on the project and it can gain traction both internally and externally. So that's a goal. Again, these things sound really straightforward when you say them. And I like to think that a lot of the topics I'm going to cover here may be common sense, but not common knowledge. And maybe you are a rock star at doing all of these, but I have learned from numerous times of trial and error of what worked and what hasn't in order to present this framework. All right, so what are the techniques? Well, one of the first things I like to do is start by listening. In fact, start by, instead of you getting up to the whiteboard and sketching out what you're going to do, something I love is handing over the whiteboard marker and say, hey, what does the technology stack look like to you? What does success look like to you? And then if that's too vague, take it down to an individual user story. One of my former colleagues was such a champion about using user stories all the time. Frequently, I would present these big, grandiose ideas, and he would say, that's great, but what's our user going to see? How are they going to walk through that experience or interface with that technology? And that's a really key way of framing it and can help you delineate the nice to haves from the needs to have. Some other techniques are, especially in these first conversations, take note of everything. If you leave with like 15 or 20 pages of notes, that's fine. I like to use successive distillation techniques where you take all the notes, you pull up the things that are the most impactful and again, so that you maybe start with 15 pages and you end up with 1 or 2. But it's better to have more documentation, especially early on than later. Another technique is, as you start to make sure you're understanding these things correctly, play it back to the user. Take what they walked you through. For example, if it's a user story, play it back to them to make sure that you're aligning, especially in really diverse work environments, which I've been lucky enough to work in. Sometimes English isn't everyone's first language, and sometimes people communicate different ways. Some are much more visual, some are much more audible, some are tactical and actually just want to act it out. That's the realm I fall in case you couldn't tell. But depending on how people communicate, instead of expecting them to communicate the way you do, try to code shift a little bit and try to adapt and be flexible and check and double check that you're aligning. Because any misalignment in the early stages of these technical requirements has a tendency to snowball and can cause significant misalignment later on. Also, separate your current and future states. It is very easy, again, to my comment of boiling the ocean, when you ask people what the technology stack looks like or what the user story looks like, again, especially with UIs, like, how do you see this looking? It's so easy to get into a session where people are venting or they're frustrated or they just want to tell you everything that's wrong with the system now, or they just want to tell you everything the system should be doing, should in quotes. But separate out those two and figure out kind of which is which. The last bit here before we actually go into the hands-on activity is a reminder that how you say things matter. Quick story time from me. After I'd finished my PhD, I was in a role where I was trying to drive and put together a project. And I was in a situation where I was trying essentially to define technical requirements. And it was really clear to me what the requirements should be. They were very straightforward, very transparent. And I kept saying things in a way that caused people in the audience to bristle. And I didn't understand. I was like, this is really straightforward. Why are you guys being so dense? And afterwards, a trusted colleague pulled me aside and was like, wow, you really talked down to us in there. Do you think we're stupid? And I was like, well, you were acting kind of. No, I don't. And I mention this, A, to show that these things can be refined over time. B, to also highlight the advantages of having trusted colleagues. But C, to really put your ego aside. In these types of environments, it is not a game to see who the smartest person in the room is. In fact, if I am the dumbest person in the room, I am in a fantastic room. It is not about you. It is not about how much more you know than everybody else. In fact, this is a perfect time to learn from everybody else and to make sure that you're speaking at a level they can understand. If you get the feedback that you're talking down to people, well, there's ways you can address that. And if hopefully it was not your intention, but if it was, it's also a really good chance to unpack kind of how this communication is manifesting itself. I say this in the sake of not only personal development, but if you guys listening to this video, the people that carved out several hours to talk about it, that shows commitment and wanting to be able to execute and drive meaningful change, drive innovation. If you really want to do that, being an effective communicator and connecting with the people you work with is a pivotal skill. I'll get off my soapbox now. All right, so let the interviews commence. For the next half an hour, what we're going to do is walk through what interviews one by one with each of our key stakeholders. Now, for the sake of brevity, I've condensed the interview notes into just a few takeaway points. But if you are listening to this right now, pull out your notes. As we go through, make note of things that are business requirements and things that are technical requirements, maybe some nice to have, and need to haves. And then we'll regroup at the end of all of these and figure out kind of what the key drivers are. All right, go ahead, pull up your pen, pull up your pencil or your whiteboard. Let's do this. All right, so for each of these interviews, we are going in order right here, starting with the technology VP, working our way down. There will be three parts. There will be the interview notes, which is just a summary of some of the key voice of the customer or voice of the individual notes. There will be a whiteboarding session where you handed them the pen and said, draw. And then there will be some takeaways that I've summarized. Notice that these are my takeaways. Yours likely will be very, very different. And that is absolutely by design. There is no one right answer here. And in fact, the more diverse perspectives we get looking at how to solve these problems, the more each of you bring your own background in, the more successful these types of solutions ultimately are. So first up is the technology VP. For the sake of this, none of these people have names or backstories or genders. They're just these amorphous individuals. So you sit down with the technology VP, this person that's been in industry for a long time. They're very polished. They're very happy to present and meet with you. And really your takeaway here is that URC, their visions are to be the rock stars of the reservoir characterization world. They want to bring together physical rock characterization with data science to really pioneer workflows in general. In fact, their methods are cost-effective, robust, and will scale to meet any reservoir. Throughout your conversations with this technology VP, you get the sense that they're not necessarily talking about the actual platform right now. They're not the person that knows the database or the structure or the format, but they're the person that can give you the overall big picture. I like to think of some of these interviews can be characterized on kind of like a 3-point axis, with how much people talk about looking backwards, how much they talk about looking forwards, and how much they talk about looking up or looking aspirationally. And again, it's kind of like an alignment. I think I really have been playing way too many RPGs lately. But with this technology VP, you're getting the sense that it's very aspirational, it's very forward-looking, very much this is what we're going to do. So then, what I did here is I went ahead and called out some of the business requirements, which is pioneer how geologists work, bringing together physical rock characterization with data science. Data science could be both. But as far as technical requirements, we get a sense that it has to be scalable and cost-effective and robust. So again, as you're taking notes of these, feel free to go ahead and jot them down. All right, and so then you hand over your marker and say, all right, well, go ahead and walk me through the data flow at URC. Very broad statement. You probably practiced this ahead of time and didn't want to bias your person, and you hand over the marker. And the technology VP walks you through this diagram that they sketch out. The workflow begins with these high quality samples. Samples that are assured in the field. We get a rock sample in, whether it's cuttings or core or thin section. But based on these high quality samples, we then use our instrument. We have a very high powered instrumental suite, which allows for these tool-based measurements, which then go into our proprietary workflow. Yes, we get the measurements, but really the takeaway here is that URC score. These URC scores in general allow data-driven E&P decisions that allow scalability with this up arrow, so scalability to meet any set of requirements, and ultimately allow more NPV per section or per well. This is all about data-driven decisions. Okay, thus concludes our interview with the technology VP. So now it's time to recap this. What were some of the key business objectives that you heard, and what were some of the key technical requirements? Well, I went ahead and took a cycle here, and it sounds like the key business objective is really combining both the physical rock measurements and the data science to provide this uniform funnel of subsurface insight. So instead of having all of these raw data, there's much less dimensionality to the data, and it's truly a novel insight. The technical requirements, it sounds like from this tech VP, they actually span the sample data, so the rocks themselves, all the way to the data science workflow. So it sounds like these technical requirements aren't necessarily just the instrument and the data science package, but instead they're much more comprehensive. Interesting to note. Good data point. Also, if you have any familiarity with the AWS well-architected framework, if not now, you'll get it later. Key into some words that typically users use to describe cloud-based systems or even on-prem systems. Things like scalable, cost-effective. We're going to come back and revisit ways that we can build a solution. We can build an architecture, a systems architecture to meet these requirements. So if you hear anything broadly that overlaps with the 5 pillars of the well-architected framework, security, reliability, cost optimization, operational excellence, or performance efficiency, if you hear anything around there, take extra note of it, because those can be real keys to making sure that what you're interpreting aligns with what the users need. All right, next up, we're going to talk to our operations manager. Now, this is the person that is on the phone all the time. When you walk into their office, they're a little bit frazzled, there's stuff going on, there's a cell phone ringer going off because this person does not like cell phones not making noise, I'm not sure. There's a lot of papers around, there's a whiteboard with some scribbles on it. And you sit down with the operations manager and you say, all right, how is the system going? Like, tell me about the platform here. And this very frazzled operations manager is just like, our customers analyze samples on the instrument. The instrument is hooked up to a laptop. They send us these files. It's a very cumbersome process. I'm always on the phone trying to figure out where these files are. They send us these Excel files. I mean, it's just tables, rows, columns, yet they're so big that they keep crashing or getting lost in email, and they send version 1 and 2 and 17 and 18, and it's such a cluster. Once we had a local computer where we were storing all these and it died. We lost so much information. Now it's just, I've taken it on myself. I make backups every week, sometimes every day, but it's so much to take care of. I don't know where the samples are all the time. I'm trying my best. There's got to be a better way. This is not working. You know, actually, fun fact, I was in a minor fender bender a few weeks ago. Everything's fine. I'm fine. We're fine. But instead of dealing with spreadsheets, I took out my phone. I had an app. I took pictures. I was able to upload photos. It was seamless. Why can't we do that? Why can't our users just use an app? Netflix and Lyft can do it. We should be able to do it. At which point you are like, all right, some of your closest analogs, maybe Netflix and Lyft, maybe car insurance companies. All right, all good pieces of data. Again, on that quadrant of looking up, looking forward, looking back, you get the sense that the operation manager probably knows everything that's ever gone wrong and could probably point you to some ways that they've come up with some clever solutions to minimize that. When you hand over the marker, this is what the operation manager sketches out. Well, the data is exported from the instrument as a CSV. That CSV is then emailed over and it's stored on the operation manager's local machine. That's the one they were talking about, taking nightly backups of data, sometimes weekly backups of data. That data, when you ask them about, so what happens to that data? Oh, well, that's uploaded to this high performance cloud database. It's all in the cloud. I don't know what happens, but somehow that is then used by our data scientists to get their outputs and send it along. So you get the sense that the operation manager can tell you about the physical machines, where the data goes, but doesn't really know what happens after it's uploaded to this magical cloud-based database. So take a few seconds, sketch out what you think some of the business requirements in here and what some of the technical requirements are, and then I'll share mine. Just looking through comments now. Yep. As you guys do this, like absolutely so many of the best practices I've seen be the most successful are translated directly from the UI UX world. There's so much good stuff out there. Yes, product managers, wait till our one-on-one with the product manager. User stories are absolutely great. And you will frequently run into users who say, why can't we just build an app? How hard can it be? Why can't we just do what Netflix is doing? How hard can it be? And to me, those are beautiful, beautiful sentiments, because it means that if you are truly at the top of your technology game and you are being on the bleeding edge of what's being done, to end users, it looks effortless. It's like seeing a fantastic gymnast perform at the Olympics. You know, you see them and you think, oh, how hard can it be? And then you try to do a handstand against a wall and fall. It's really, really hard. But if you do it well, it looks effortless. All right, so here are some of the business and technical requirements, the business objectives and technical requirements that I got talking to the operations manager. First off, they really want to streamline sample data acquisition from the instrument to the database. Again, you don't know what this database looks like. They also really want this good customer experience. And this is one of our first pieces of data that the customer has feedback on the experience right now. The fact that they're calling the operations manager is a clue, tells us something. As far as technical requirements go, ability of users to upload CSV file instead of emailing it, that's something we can help out with. Also, they spoke about disaster recovery and reliability. So there's some other technical requirements there, like can the system automatically back up? Can we ensure uptime? What are our reliability measures? We'll go into this later. And then also streamline app-based interface. All right, we'll jot it down. Revisiting, like upending the entire flow and developing an app is probably going to be on the nice to have, if not the parking lot, but it is a great technical requirement to be aware of, especially if you can connect that with key customer outcomes. If having an app can ultimately boost sales or boost usage or have a larger ROI for the company, that can be a key way to get there. All right, next up is the developer. Now, you walk into the developer's room and you just smile. In fact, you see a laptop, you guys can't see the back of mine, but it's covered in stickers. And you walk in and you see a Lambda sticker, you see a little AWS sticker, you see an AWS game day sticker on it, and you're just like, yes, you are my people, developer. You and I speak the same language. Let's roll up our sleeves and get into it. And in fact, you have a great conversation with the developer. They are an AWS fan to the T. They are all about doing whatever they can do. And they say, you know, when I came here, it was a mess. There were local files everywhere. There was no unified truth. And I love the cloud. What I've done is developed a system taking these CSVs and we upload them to DynamoDB. They have all kinds of additional features that are added on to DynamoDB. They have shards enabled. They're capturing changes with streams. And this developer is actually thinking about using DAX, which is a DynamoDB accelerator, for that microsecond latency that they need. Anyway, they have a great setup here, but they want to do more with serverless, like using Amazon Aurora and more automated tracking and deployments to ensure that as new features are rolled out, they can implement them right away. The developer says that the data scientist should be able to really easily spin up Amazon SageMaker instances and run their Jupyter notebooks, pulling directly from the DynamoDB instance. They're not sure if they actually do that or not, but they wrote the documentation. There's a wiki on it, and the wiki is fantastic, but you know, guys, really, no one reads the wiki. I read the wiki. So this is the sense you get from the developer. Again, looking at this, they're thinking about microsecond latency for their workflow. Now, even if you're not that up to speed with what the services are and what the standards are, my professional opinion that this is probably a very over-engineered solution. This is something that probably has a lot of horsepower behind it and maybe doesn't need to be that efficient and that engineered. But you ask the developer to go ahead and whiteboard things out, and they say, whiteboard, I've already done this. We have an architecture diagram, and it's beautiful. I did it myself. And what they do is pull this up. If you have never seen these figures, I'll just go ahead and walk you through what it is. But essentially what's happening behind the scenes is that these CSV files are being uploaded to an S3 bucket. We'll talk about S3 buckets later, but it's essentially an object-based storage in the cloud that has really good durability. Once the CSV files get uploaded to that bucket, they then undergo some transformations as needed with Lambda. Lambda is a serverless service that can just execute code. So when these very large CSV files comes up, the Lambda will scan through them. It's a bunch of Python scripts. It'll go through and see if there's certain measurements that are included, certain measurements that are not included. And depending on what's there, it will add tags to that S3 file. Those tags then trigger off additional code packages that run and help to pre-munge the data, get it all straightened up. And then it goes into DynamoDB. Again, we'll talk about databases, but DynamoDB is a NoSQL database, very scalable. It can pretty much handle anything you throw at it. And all the data goes there. There is a connection between the DynamoDB and the SageMaker, which is this logo here, so that data scientists should be able to go directly into SageMaker, click, launch their instance with full scalability. And this developer has really identified pain points within this existing architecture and has completely minimized them. I want to take a step back for a minute. The title of this talk is talking about scalable and resilient systems architecture. And as we go through whiteboarding and as you go through these conversations, it's really important to identify where the potential bottlenecks are and where the potential pain points are. Now, here they were talking about, the developer is talking about DAX, or a DynamoDB accelerator that can help with caching and decrease times to microseconds, which is a great way to increase your speed and decrease your latency. But for this type of system, it doesn't really sound like that was a bottleneck. That's not something that has been referenced by anyone else so far. In fact, uploading the files to the CSV, that manual step in the journey where the files get emailed to the operations manager, they then upload the CSVs to the S3 bucket, that is a bottleneck in the system. So it's important to delineate those, even though no one has directly said that. When you start to think about how all of this could handle 10 times or 100 times as much traffic, where are the parts of the system that may break? All right, but you thank the developer for their time. You actually have a spare sticker hidden in your notebook because you always keep a secret stash of AWS stickers. You hand them one they don't have, and pretty much you have a new best friend. You bond over mechanical keyboards, although they prefer red switches, and everyone knows brown switches are the best, but that's a whole aside. It's a great way to spend your time. All right, so here is what I've pulled from the developer. Again, if you have different requirements, that is fantastic. But it sounds like the developer is really translating everything into scalable and automated data handling. The requirements are CSV file, going into a bucket, into a database, machine learning. Someone on Slack just nailed that. That is absolutely the technical requirements. Another thing you heard here is this ability to deploy new technology and experiment more often. That is frequently, from a personality perspective, I tend to find that some stakeholders love new technology. They follow the AWS post, they follow the trends in cloud computing, and they want to even do things like, hey, Amazon Bracket just got launched. It's quantum computing. Can we do that? Well, no, that might not be a great use case right now, but it's great you're thinking about that. Whereas other stakeholders really like their favorite pieces of technology. They love their Oracle databases. They love their Postgres databases. They love their SQL Server databases, and they really want to hang on to those. One is not necessarily more right than the other, but making sure that the appropriate technology packages are included to allow for the most flexibility and the most optionality in line with a well-architected system is something to be aware of. All right, so we only have 2 interviews left. We have the data scientist, which you're interested in, and then we have this product manager, this one person that supposedly knows everything about the product, and we're very excited here. Well, next up, we go ahead and sit down with the data scientist, who, when you approach them, they have their phone, they seem a little frazzled, they're doing a lot of things. They have about 17 bazillion tabs open on their browser. You can't see mine, but it's probably also very similar. And they're running through lots of analyses at the same time. And you're like, all right, data scientist, let's meet. And you talk to the data scientist and you're like, hey, how are things going? What's the deal here? And they say, oh, yeah, you just talked to the developer. I know that's how the process is supposed to work, but honestly, it's a pain and I do things differently. I'm too busy on the phone with customers continuously trying to execute. I don't have the time to document what I'm doing. If I wanted to actually make this whole thing a thing about how I'm doing the analysis, I would, but I'm just so pressured by trying to deliver on our customer requirements. I don't have time from that. I got to triage my time. Customers love what I'm doing. I always get positive feedback. Our projects go very successfully. So I figure I'll just keep doing things my way until I have it figured out, and then we'll worry about changing the system since our customers are rock stars. We want to help our rock stars. Let me just do what I'm doing. It's working really well. And you're like, okay, cool. Customers are rock stars, picking up on more of those themes that the technology director first mentioned. But you're also getting a sense that even though the system may be designed, this data scientist doesn't have the time to read through the documentation and adjust their way of working. So you, instead of handing them the marker, you actually decide to take the architecture diagram that the developer gave you and you pull it up and you say, all right, how does this work? Here is how the system works, what's working, what's not. And the developer laughs. And laughs, sorry, not the developer, this slide is mistitled. The data scientist laughs and laughs again and laughs a third and fourth and fifth time. And says, yeah, everything should work in the cloud. I get that. Honestly, though, I got locked out of my account with multi-factor authentication, and I haven't been able to get into SageMaker ever. And I didn't really get around with it. I had other stuff going on. So I just decided to do it differently. I go into DynamoDB, I download all the information I need, I export that as a CSV, and then since we're cloud-based, I put it up in my own cloud instance and export the CSV for customers. And at that point, you're calling a timeout. You're like, well, how are you running your notebooks? SageMaker is designed to be very scalable. You have integration through all of your security best practices like how are you actually getting access to the cloud? And the data scientist is like, oh, I have access to the console. I just spun up an EC2 instance. I installed Python and I'm doing everything there. In which case you're like, well, that's great, but how are you storing your data? Are you referencing the DB? Is there an endpoint? Are you talking the S3? Oh no, I have this great system where I just figure out how much storage I need. I make a big drive that's that big and attach it. And then when I'm done, I just step away from the instance. Sometimes I forget to turn them off, but whatever, it's fine. The customers are getting what they want, and you chuckle. And I chuckle because honestly, like this, from the outside, this is a system and a data flow that is meeting their primary demand of delivering URC scores and data to their customers. There is nothing here that is truly egregious. It looks, as far as you can tell, it's in line with security best practices. The data is being handled in the cloud. Yes, there's a lot of manual steps. Yes, there's a lot of areas that could be streamlined, but the data is being backed up in DynamoDB. So there's a single point of truth. Their EC2 instances, maybe they have snapshots. Like, it's not egregious. It's just not efficient, and it's not well architected. And unless you have a sense of what the guardrails are for architecting a solution in line with the best practices, this might actually be okay. And you know what? You can't blame the data scientist. They are answering the primary mission of the company of making sure their customers are rock stars. So they're knocking it out of the park there. However, we can do a little bit better here. In fact, we can do a lot better here. So we have one more interview and we are set to meet. Oh, sorry, real quick. Again, this slide is mistitled. This should be the data scientist, but you get a sense talking to them that the business objectives here are to really create that effective and scalable process to ultimately share these subsurface insights with their customers. Technical requirements. We need to connect that database to that Jupyter notebook in a way that is really, really easy. And we need to go from that Jupyter notebook to end customers. And we need to spend less time moving CSV files here and there. But we have our business and technical requirements. Now let's go on to our product manager. Our one person, this should be our best friend, the person that knows all about everything. And so you sit down, ready to take notes, talk strategy, talk roadmaps. And this is what the product manager says. My singular goal is to make URC the paradigm shift in how reservoirs are characterized. Together, our high-performing team is keenly aware of what our customer pain points are, and our focus is to over-deliver industry-leading metrics using the next generation of AI and ML workflows. This is why we're so keen on the cloud. We are empowering customers to ride URC unicorns into the cloud. Well, that and stay within budget, actually. This is all great, but we have gotten some really sky-high cloud bills lately, and we really probably should look into that. I mean, unicorns need to have money for food and ping pong tables, right? At which point, I don't know about you guys, but I chuckle because not only have I had this conversation with various stakeholders, I have been the one sitting there before I knew better, pretty much checking off buzzwords off a buzzword bingo scorecard because I thought I was translating value and I was sounding like I was an innovator. But it's fine. You talk to the product manager, you hand them over the marker and say, hey, what does the technology stack look like to you? And again, they are really focused on this URC score. They get these next generation insights, the scalable characterization, the data-driven reservoir workflows, and pretty much everything you learned in your homework. Back when we were talking about doing research on your customers and seeing what existing collateral is out there, everything the product manager gave you is available online. It's not good or bad, it's just the way it is. So then when it comes time to translate business and technical requirements, business objectives pretty much seem to be like buzzword, 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 paradigm shifting, awesome, innovative, unicorns, that's fine. And the technical requirements that you heard underneath all of these layers of abstraction are cost optimization. We're going to revisit that when it comes time to delve into the well-architected framework. All right, we are just about to our break. We have conducted all of our interviews. It's been a whirlwind. You have met a very robust cast of characters, hopefully learned some things along the way. Again, these are all fictitious. I have not met these actual people, although I'm sure we will one day, and they'll be magical and they'll have unicorns. So what do we do now? We have pages of interviews. We have a sense of who some of the cast of characters are. What have you learned so far? Well, you've learned the backgrounds of each of these stakeholders. You've learned how they view the technology, how they view the pain points, and kind of how they view the future. But how do you guys think it went? In Slack, real quickly, do you think it went well? Do you think it went okay? Do you think this was a waste of your time and you could have done it without talking to anyone? How do you guys think it went? My perspective, as the person that designed the scenario aside, I think it actually went really, really well. Having honest and frank conversations is so much more important, especially at this phase of the journey, than sitting down with people that just tell you, oh, it's great, everything is wonderful, or just give you the same insight again and again. Much like diversity is absolutely crucial to building high-performing teams, having a variety of perspectives when you're looking at what this solution could be or what this workflow could be, having people look at it from all kinds of different angles is such a key advantage. If everyone said the same things that the technology VP or product manager said, that would be fine, but you'd have to make a lot of inferences in the best way to execute. Some of the best sources here are the voice of the customer feedback that you hear from the operations manager and the data scientist, as well as the fact that the developer is very tech savvy and very willing to work on trying new things out and maybe just needs some more guardrails. So I think this went very well. Definitely have enough information to help carve some stuff out, develop next tactics. But what I want to wrap up this section with is really going over all the business objectives and technical requirements. As a solutions architect and as someone that's been in commercialization and scaling of technology for about a decade now, you can't necessarily turn in a 50 number one key objectives. In fact, having enough courage to say this is what we're not going to focus on is many times more important than figuring out just what you are going to focus on. So our first activity is going to be taking all of the business objectives and technical requirements that we talked about. You're going to take these, and I want everyone that's called in or listening or watching the replay, give me one business objective, the one sentence, the overarching sentence, and then give me the need to haves for technical requirements and the nice to haves. I think, yep. So we are going to spend 5 minutes doing that right now. And then I will talk about what I've put together very briefly, and then we will take our first break. I'm going to go ahead and check out this Slack as you go ahead and work. If you have, again, questions, comments, want to talk about anything, feel free to bring the conversation over to Slack. Here you go. Oh, these comments are great. Please, please keep them coming. And again, please put your business objective sentence in there, put your technical requirements in there. Awesome. Yeah. Business objective sounds like people are saying take samples from collection to production in an automated way to improve production for customers in the end. Absolutely. Streamline, automating insights. Yes, absolutely. Um, yeah, lots of also really great comments about how many different views there are in these organizations. I'm sure many of you have also worked in these types of organizations where you hear someone explain the situation and you're like, hey, that's not anything at all like my experience. And again, from a professional development perspective, sometimes it can be really easy to be like, wait, no, what world are you living in? But recognizing that reality is not always objective. In fact, a lot of times it's filtered through the lens of who's observing it can be a key prerequisite to really making sure that you can align and help to drive these outcomes. Yep, reliability, simplicity. No one here said the main business objective is like really sweet app development, which I'm going to go ahead and share what I've come up with so far. Um, yeah, and to me, it seems like the business objective is to create scalable processes to take data from the instrument and deliver machine learning based analytics workflows to E&P customers. Absolutely. I think everyone you've talked to can probably understand that that is the overarching goal. It's just how they slice and dice that varies. As far as the technical requirements, I've interpreted an architecture that spans sample analysis to data science results. I know the technology VP did talk about sample constraints in the field. To me, that's more of a nice to have. That seems outside maybe the initial sphere. But for some additional guardrails, the input data is a CSV from that quantitative analysis machine. The output data is a Jupyter notebook for analyses. Nice to have would be some kind of analytics platform or some kind of customer facing import export data. And then technical requirements, something that's cost effective, scalable, reliable, and decreases the hands on time for the data pipeline. Those all seem to be really core. How those boundaries are defined can change a little bit. And again, different perspectives are key here. Nice to have that sample metadata, more information about the samples themselves, a platform to deploy new technologies and solutions. So whatever that looks like for customers, how they're using it in their environment. If there's a plugin for a petrotechnical solution package, that could be great. If there's a customer-facing analytics window, that could also be great. Nice to have would be a really streamlined way to export and share data with end customers, but you don't quite know what that looks like. And also some kind of integrated data validation and cleanup. One thing that you didn't really get a sense of here is what happens if something goes wrong. If it's a bad sample, if the instrument is miscalibrated. But in your experience working with NoSQL databases in particular, without the rigidity and validation of working with a SQL-based database, there could potentially be some room for what is recorded and what is characterized to ebb and flow. So that's another thing to keep in mind. All right, now we are going to go ahead and take a 10-minute break. And then when we come back, we are going to deep dive into some key AWS services. So it is 2:03 p.m. CDT right now. So we will regroup at 2:13 p.m. CDT. I'll stick close to chime if anyone wants to ask questions. Otherwise, I will see you guys back in 10 minutes. It's 9 minutes now. Welcome back. I hope you had an enjoyable break. All right, so for the next half an hour, we are going to talk about services, solutions, and scalability. The learning objective here is to know more about some of the key AWS services we're going to talk about, and more importantly, where you can go to learn even more. So we're going to step through these at a pretty high level. It should be about half an hour, and then we can take a little bit of a break in there again as needed. So based on the survey results, it looks like about half of you have in fact logged into the AWS console before. In fact, 60% have, 40% have not. For those that have no idea what I'm talking about or even where to get started with AWS, I'm just going to take a quick step back. Essentially, at its core, cloud computing is the ability to use the internet to have access to IT services. If you have never played with AWS or don't even know where to begin with it, I'm going to show you the absolute best place to get started. And that is, I have these hidden Chrome windows here. That is to go to aws.amazon.com. When in doubt, start out here. You can get a free tier eligible account for your first year, and you can click sign into the console. Through the magic of technology, I have already done that. And when you log into the AWS console, this is what it looks like. I mentioned that because if we go back to my slides, my next shot here is a screen grab of the 200 plus services that AWS has, with some of the key ones highlighted in orange. Now, I want to mention that because when you log into the console, if you're looking for something in particular, for example, SageMaker, you can type it in and it will pull up. But if you have never been here before, you can scroll down at all of the services. Here's Amazon Bracket that I was talking about earlier. Here's your S3, here's your EC2. We have managed blockchain. We have this whole chunk of security services. And oh, hey, there's our SageMaker, but there's also all these other machine learning services. So if you have never logged in before, and I know the first time I logged in, I was like, well, ginger snaps. This is a lot of information. I don't know where to start, and in fact have such decision fatigue. I'm just going to walk away because what if I start in the wrong place, or what if I'm totally off base? Totally normal fear. One of the best places to start is if you scroll down to the bottom, you can right here build a solution. You can use Lightsail to build using virtual servers. You can connect to an IoT device, or you can also learn to build with these different tutorials and labs. As we step through these slides, I'll give more tips for learning more about individual services, including the option to get AWS certified, to have external validation of your knowledge. But if you are terrified and scared of building anything, the first place to go is to budgets. And you can go to budgets, you can set up a budget alert. I have one that says if I spend more than $20 a month, it will send me an email. There's a lot of tutorials online you can follow along with. Set up that alert so you know you're not spending more than you expect, and then go ahead and build. Play around with stuff. For instance, if we want to spin up an EC2 instance real quickly, we'll talk a little bit about EC2 instances. You can just click launch instance right there, and then you can follow along, and you will see some of these that say free tier eligible. And by paying attention to the documentation and looking into tutorials, you can really quickly start to build stuff right away. As we go through some of the differences between some of the services, you will get more insight into some great ways to get started. If you have any questions, feel free to reach out to me, especially via LinkedIn. I post a ton of content there. All right, so where to begin? Well, I talked briefly about some ways that you can take tutorials, get started learning a little bit more, but I want to level set a little bit higher. And if you are truly completely new or still learning about building on the cloud, one of the best places to get started is looking into serverless applications. Now, when I first heard the term serverless, I was like, wait, if there are no servers, where does the computer stuff happen? Well, with servers, the servers still exist, but they're outside the realm of things you need to think about. Serverless applications and serverless products and solutions like Amazon S3, which we'll talk about, or DynamoDB, which we heard about previously, the servers still exist, but instead of worrying about patching and maintaining and some of that undifferentiated heavy lifting, you focus on what you need. So with DynamoDB, you focus on the data that you upload to DynamoDB and the data you get from it. You don't worry about patching or too much about how to scale it or what size instance you need, and it allows you to shift the focus. I know other people that are more historically IT savvy. Serverless to them is seen as something you kind of progress your way into and get understanding for. But from my perspective, as someone that learned the cloud hands-on, jumping right into serverless applications was a lot easier because I didn't have to worry about, oh, do I want a T2 Excel? Do I want an M5 database? What do I need? I could really just focus on what I was doing. And so this is also a great way to start. Some of my favorite building blocks for serverless applications are on the screen right now. I am going to deep dive into S3 and DynamoDB. Then we'll pivot and talk broadly about databases, and then we'll also talk about some of the other features to be aware of. If anyone has any particular comments, questions, again, feel free to ping a question in the Slack. All right, so the first service here we're going to talk about is Amazon S3. Now, S3 is probably one of my very personal favorite solutions. And essentially what it is it's a web accessible object storage. You have something you want to store online, Amazon S3 is your go-to for that. The way it works is when an object is uploaded to S3, the standard storage class has 11 nines of durability. That's 99.9999999% durable. So when you upload something, you know it's going to be there. Well, how does that work? When an object is uploaded into S3, it is stored in at least 2 different availability zones. Now, when we talk about availability zones and regions, let's just level set real quickly. An availability zone is a collection of 2 or more discrete data centers that have redundant power, redundant networking, and that are geographically distinct. And a region is a collection of those. So data centers to availability zones to regions. When we talk about the well-architected framework, knowing how those terms interrelate to one another is going to be important in deciding if you have really important data that you want backed up, like our operations manager earlier, once that data is in an S3 bucket, it's not going anywhere. For all practical purposes, that data will be here long after anything else we need to worry about is gone. And so if that's the case, taking additional backups of that from an on-prem machine are really unnecessary and can be an unnecessary expense and pain point when looking at a scalable workflow. To control access to an Amazon S3 bucket, you can use both bucket policies and access control lists, which can help to make sure that only people can access what's in the bucket that you want to while keeping everyone else out, and they're limitlessly scalable. It can be a really great solution if you need to just store objects in there, keep them there, but it can also be a place to integrate with a lot of your other Amazon solutions. In the workflow we talked about earlier with the Lambda functions, once those CSV files were uploaded into that S3 bucket, there were Lambda functions that were triggered, returning the objects to the S3 bucket again, and then they could be uploaded to DynamoDB. So these are an essential building block in putting together a cloud-based solution that also meets your disaster recovery objectives while being very scalable. One of my favorite ways to share large files, in fact, is to upload them to an S3 bucket. If you want a fun little hands-on example, and to create a URL to share them with. So you can upload them, you can create a limited time URL so that someone can access your material. It's called a pre-signed URL. It's my favorite way to share massive files. Additionally, there are a few different flavors of S3. Now, we talked a little bit about this S3 standard, which has millisecond access. Its material in there is backed up in at least 3 unique availability zones. However, with that durability comes a trade-off for cost. And in fact, if you're looking at building a cost-effective infrastructure, being aware of what these different options are for S3 is one of the ways you can ultimately meet cost objectives without any change to ultimate user performance. In general, the different types of S3 are based on access frequency, and there's also lifecycle policies that will take objects in an S3 bucket and automatically move them to different storage classes based on how much you use them. But if you know that you have records that you just want to back up, you are probably never going to look at them again. And if you do, you're okay waiting 12 or 48 hours. This S3 Glacier Deep Archive is a very, very cost-effective solution. In fact, if I was working with the operations manager and he or she, they were very reluctant to part with their backups or any information they had and yet wanted to move to something that was more scalable, pop those into a deep archive bucket. They are there. You will likely never see them again, but it is very, very cost effective. All right, so broadly, these are our different flavors of Amazon S3. Again, depending on what your use cases are, thinking about the different versions of each service is a really smart way to design a system that meets your technical requirements and your business requirements without impacting any of your user outcomes. All right, next up is DynamoDB. I actually have a sticker for DynamoDB on the back of my computer. DynamoDB is a non-relational database. It has really fast, predictable performance. In fact, if there's a really good use case where you need to store a lot of data, you don't know what the schema is going to be ahead of time, you want it to be really scalable, especially in web backends, this is your go-to database. The administration is very straightforward. You can actually access it through the console. You pay for what you need. It has a RESTful interface, so it can connect with a lot of your other components behind the scenes, and it's very, very fast and very, very scalable. As far as durability goes, that was one thing that we heard from a few of our users earlier, is that they had different requirements for disaster recovery or durability. And data in DynamoDB is automatically backed up into 3 different availability zones. So you have it there, it is yours. And as a service, you don't have to worry about managing and patching of the infrastructure as you would with other database instances. So DynamoDB, it's easy, you can run with it right away. And that is what our users, that's what our developer at URC had been using, was DynamoDB, which is a great service. I love it. Don't get me wrong. There's additional features for this DynamoDB accelerator, this DAX that we talked about. But it kind of begs the question of, okay, well, why? And what are other options? So real broadly, we're going to take a step back and just really broadly talk about data categories and data use cases. If you come from a database perspective, then you probably know more than most people about relational versus non-relational databases versus document databases. But as with the working backwards methodology that I talked about earlier, figuring out what your data looks like, figuring out what the storage mechanisms are, what the inputs and outputs are key to figuring out the best way to store it. I alluded to this in one of the very early slides, that one thing you may or may not want to say is like SQL or no SQL when you first sit down with the team members. But there are very strong opinions about this, and there's very great use cases for different types of database structures and different times when you maybe should not use them. Now, broadly, here's a few of the AWS data categories with the AWS services at the bottom. I put this up here because the use cases, as you can see, vary from data set to data set. If you really need a schema, if you need the validation, if it needs to be an ACID transaction and you need that type of structure, there are several AWS options. There's lots of options from database construction. You can go the RDS option, which can support databases like MariaDB or Postgres. Postgres is probably my personal favorite. In addition to Oracle and SQL Server. However, if you don't need that kind of structure, but if you need really high throughput, low latency, and you need to be able to scale this thing to the moon and back, DynamoDB is going to be a great place to go. A lot of our customers use that for shopping carts, for a lot of those web backend applications for storing customer preferences. However, if you really need fast but relational database, then there's Elasticache, which is mentioned in the in-memory, which can also integrate with RDS to help provide a low latency solution. So those are some of the existing flavors. We have DocumentDB, which is really great for document access with things like mobile applications, content management. And we also have graph databases and time series databases. Graph databases like Neptune is the AWS version, but they're a very quick way to find relationships between data. If you have a social networking application, if you want to look at fraud detection, especially when it comes for the financial sector, graph databases are a really great way to visualize that data. I am not aware of use cases where graph databases are being used for geology right now, whether it's for like elemental analysis or for some stratigraphic work. If there are any, please reach out. I'm really interested about that. The other type of database we have here is time series data. Now, if anyone here has worked with time series data, especially tried to fit ML analyses to time series data, it is a whole separate can of worms. In fact, event tracking, figuring out what your baseline is and what deviations from that baseline are a key component in predictive maintenance applications. And in the energy space, there's a whole range of things that can be done. TimeStream is the AWS service here. I also want to quickly mention, though, that in addition to all of these services, AWS has a partner network, which is a global network of both technology partners, ISVs, and consulting partners that launch customer-focused solutions. One of the partners in the time series data space that is doing some really fantastic work is Seek. And if you're interested in really refining time series applications, in addition to TimeStream, be sure to check them out because time series data is truly unique. The other option mentioned here is QLDB or Quantum Ledger Database. If you need immutable, verifiable history changes to all application data. All right, so here are our cast of characters here. Now, what I want to do is take a quick minute, let me pull up the Slack here, to connect some of the technical requirements that we talked about earlier today and that we heard from our stakeholders at URC. How do their technical requirements for storing and querying data align with some of these data categories and use cases? If anyone has thoughts, feel free to post that up there. But in general, some things we heard a lot about DynamoDB. We also heard that the data coming off, the input to all of these systems is the data coming off an instrument. And if data is coming off a hardware or an instrument, it's likely going to have some kind of structure to it. And one of the first places I would interrogate is why are they using DynamoDB and not a relational database? Is there value to having the flexibility of a non-relational database that just wasn't brought up? But if we know that that instrument is going to give us the same 27 measurements every single time and they are not going to change, by moving over to RDS or something that is a SQL type instance and having that relational component, we can do validation ahead of time. We can do things like check the data to make sure what's entered aligns with values that we need. It means that we can double and triple check that we have the correct number of digits of precision and the correct fields. So that is one area that you can right away start exploring and poking into when it comes to data management. In general, transitioning from NoSQL and SQL back and back again is something that I would caution everyone to avoid as much as possible. It can be a giant pain, but if you do have the option to have that validation and have that structure, typically I find that retaining that for as long as possible can be helpful. All right, next up, let's go ahead and let's shift gears a little bit. We had a mini deep dive into database and database structure. Next, I want to talk about Lambda. Now, I mentioned Lambda a little bit, but essentially Lambda is code. So it lets you just run snippets of code without provisioning or managing anything. You only pay for the compute time you use. It's an AWS-owned infrastructure. There's built-in fault tolerance. And if you want to scale this, You can scale it by sending more requests. So if you have a piece of Python code, for example, when we looked at our architecture initially, once the CSV files were uploaded, we had some kind of Lambda function to munge the data, to reformat it, to restructure it. So if you have that data being uploaded, you can actually trigger Lambda to run based on those upload events. And the event source can be a change in data state, it can be a response to an endpoint, or a change in resource state, or that object actually being uploaded into that S3 bucket right there can trigger the Lambda function. There's a variety of languages that Lambda can work with. Again, I use Python because that tends to be my go-to. But it allows for a lot of flexibility and a lot of scalability. From there, the output of Lambda can also go into another AWS service. It can stay in the cloud. It can couple to something like an SNS or a simple notification service, and it can maybe send you a text message along the way. Maybe it's uploading data in a database and you're able to get notifications for that. Lambda is really that go-to first step. If you just have small pieces of code, you can put it in here and there for a lot more scalability, and it's serverless. So you don't have to worry about some of the backend we talked about. All right, so that's Lambda. I want to shift gears a little bit right now and talk about the AWS machine learning stack. Yes, this is a very busy slide. When I pulled up the console earlier, I mentioned SageMaker and a whole bunch of other AWS machine learning services in there. I want to unpack those and provide a little bit of additional structure right now. So essentially, the AWS machine learning stack operates on 3 different levels. At the very base of the technology stack, we have tools that are go-tos for very experienced machine learning practitioners. So if you are great with TensorFlow, if you really are an expert level user, there's a whole series of services that can meet your needs. However, if that's not your level of expertise, there is this middle layer right here of services such as Amazon SageMaker and SageMaker Studio that allow you to quickly and easily provision Jupyter notebooks, to run experiments, to do things like host and monitor your models and then scale those. So that's really this intermediate service. I could probably talk for a long time about each of these, so I'm going to try to keep this high level. Some of the additional services, though, are on this top level. These are fully managed AI services. So these range from things like Textract and Comprehend to search and chatbots, but there's a wide variety of services that have API connectivity so that if you want to embed aspects of machine learning into your workflow, this is your front line. There are some definite power players here. Okay, so for example, let's go back to our architecture we've been describing. Let's say that we want to expand it and include some additional metadata from the field. In the field, maybe there isn't great connectivity, maybe we don't want to build our app right away, and maybe we're getting handwritten notes, or maybe we're getting forms that are filled out in the field and brought in. Well, you can take those forms, you can run them through Amazon Textract, and it will automatically recognize the forms and it will pull out the data. So you can have that PDF or that image file in your S3 bucket. You can run it through Textract, return the values, which can then undergo authentication and directly go in your database without someone manually typing it out and writing it out. That is a very key service in the way that you can extend your functionality and extend your offering to align with meeting customers' needs without too much work from you on the back end. Another service I want to mention right here is Comprehend. Comprehend is my favorite if I have a lot of data, if I have like a PDF with a lot going on in there, and I'm curious as to what the sentiment analysis is, or if I just want to get some keywords so I know how to describe that very succinctly. You can actually log into the console like I showed you earlier, go to Comprehend, you can copy paste from a news article, for example, run that through. It'll give you what the top keywords are in there, what the sentiments analysis is, and then some of the probability associated with that. Now, that's a great use case if you have a lot of unstructured or semi-structured data and you want to throw in some type of search functionality or some type of analysis with that multitude of text files or PDFs. There's a lot of other really great services in here. Amazon Recognition, you can upload images and it will tell you right away and what the probability is of like, who is there? Are they male? Are they female? Are they smiling? What is their facial expression? What is their sentiment? And so right away, you can start to find ways, if you think creatively, to interact these high-level AI services with your existing backend. And again, one of the advantages of doing everything in the cloud is that it's very easy to connect and get these services talking to one another. All right, last up, I want to provide a really high-level overview of what the energy data platform is in general. When I have conversations with oil and gas customers, how I think through how data kind of goes up, how it gets referenced, and how data flows. And then I want to wrap up with some security solutions before we take a quick break. So broadly, the AWS data platform is broken into a few different layers. But when I think about this, it really starts with where the data is. As a geologist and someone who's interpreted lots of seismic, I'm typically used to thinking of my data as living somewhere, whether that's being migrated from tape, whether that's in some big server room somewhere, or maybe it's data being streamed from the field using WITSML. Once that data comes in, it's all about how you store and get access to that data. So I talked a little bit about tiered storage with S3, but also who has access, who doesn't. How is that data cataloged? Are you using something like I mentioned earlier with Comprehend or Textract to know where that data is? Or do you just have pools of dark data living somewhere that you assume someone with great institutional knowledge will know that my services that are called blue _ final _ 2 _ above salt, that's my real important service? Or do you just kind of risk losing access to that data? And then when it comes time to discovering that, how is that done? Is there search functionality? Is it through a console? Is there a broader microservice architecture that uses APIs to communicate? And then finally, all of that leads to that analysis layer. Here is where we have both the classical petrotechnical applications we all know and love, as well as the machine learning applications. And even though this is a box, I think of it as a little more of a pyramid. Because if you're doing really innovative machine learning work, you are only going to be able to do that on the foundation of what's underneath it and what's funneling into it. I understand that a lot of times we step into data ecosystems where the framework and the historical work has already been done, and it's a little more myopic about what we can control. But even being explicit about where the data is, how it's being stored, and what your critical risk factors are can be a very crucial way to ensure that you have insight to potentially the limitations of your own analyses, or you're able to work to break down all of these silos and truly run innovative analyses. We have a lot of AWS partners that are actively engaged in figuring out the best ways to really tear down these silos, get the data talking to one another. And there's a ton of really great projects that are being done. My suspicion is it's not a one-size-fits-all approach. So please feel free to comment in the Slack with things that you've seen work really well, maybe not work so well. I know I have my favorite partners and their solutions, but I kind of want to flip the tables and hear what you guys are using. All right, so last up, I'm going to briefly talk about security infrastructure. So is the AWS cloud secure? Yes, and security will always be the top priority. AWS has been architected to be the most flexible and secure commercial cloud platform available. And due to that, there are a range of different measures that can be done to help you protect your data. These range from security tools such as Shield, which is DDoS protection, to Amazon Macie and the way VPCs are constructed, to identity management tools like IAM or Identity Access Management and AWS organizations to make sure authentication and authorization are taking place hand in hand, in addition to encryption tools and compliance tools. So there's a huge platform about security. I mention this again because we're going to talk about security a little bit more in the well-architected framework. And It's something that needs to be the primary objective in any architectural design. Yet, if you think back to the stakeholders we talked to, it's something that we didn't hear from anybody. And we'll poke into that a little bit more. All right, so if you're interested in learning more, some of the great ways to get started are joining AWS user group meetups. I host one in Houston about once a month, making connections on LinkedIn. I have a series of videos I've posted. But if you're a practitioner and you want to share that skill set, look into AWS certifications. I have both my cloud practitioner, all of my associate level, and my solution architect professional certifications. And those are great to show that you are a practitioner of AWS services and can be a great way to align with other stakeholders within organizations so that you know how to calibrate the level of technical sophistication you use when you talk to them. And you can make sure that you are doing everything to speak the same language, come from the same skill sets, and make sure that your expectations align. All right, so real quickly, we're gonna take just a 3 or 4 minute break if anybody wants to. I'm gonna look over questions and reply to them on Slack, but let's go ahead and take a quick break and we'll regroup at 2:50 p.m. CDT in 5 minutes. Awesome. Welcome back, guys. All right, next up, we're going to talk about whiteboarding as a superpower. The learning objective here is I want everyone to leave with at least a few more techniques to using whiteboarding to help tell compelling stories. Again, if we were in person, there would be a beautiful whiteboard behind me. I would show up with like 27 different color markers, and we would do a really interactive hands-on activity. Since we are virtual, I have a tablet right here with a pen, and we're going to go forth together. One of the realities of the world that we are living in today, for better or for worse, is that the chances of getting together and doing in-person whiteboarding tends to look a little bit fewer and farther between. However, whiteboarding is still an essential skill to help break down data. So let's go ahead and get started. Well, why whiteboard? Why not just have PowerPoint slides that we pull up? I mean, I think that's probably self-evident. Why don't we need more PowerPoint slides in the world? Well, at a really high level, I like to err on the side of fewer and fewer PowerPoints. Additionally, I have a little whiteboard pulled up here, as you can see on my screen. And whiteboarding allows you the chance to go on a journey with your customer or with the people you're on together. You can do things like pick color schemes. You can draw things out, like here is my name in case you forgot it. But it allows for more flexibility and a lot more of an informal nature to your conversations. I find that in the few times I've been doing digital whiteboarding, my drawings are sloppy and they are messy. And for some reason, in person, they seem to always look good, but online, they're frequently less than crisp and precise. But honestly, I'm okay with that. It's a shared sentiment to bond over, and it's another reminder that, we're not all total perfectionists, and sometimes your VPCs look a little more squiggly than straight. Additionally, two other keys here. One is inclusiveness. If you have someone on the team who is a very visual learner and who can draw very complex diagrams, that might not come across when you're just speaking. Also, it can be more comfortable for people to turn away and sketch something out on the whiteboard as opposed to staring at you and making direct eye contact. Another advantage here is something I like to call progressive disclosure. That is a educational technique that is known far and wide. But essentially, if I were to draw out a cloud diagram, I can step you through it as we go together. So here we have, let's say for the sake of argument, here is the AWS cloud. You'll know because there's what looks like a popcorn kernel, but is actually supposed to be a cloud there. And maybe within that cloud, I want to talk about regions. I talked a little bit about the region concept earlier, but maybe we'll call this one region A. And maybe within that region, I want to talk about different availability zones. I mentioned earlier that availability zones are collections of one or more data centers, each with discrete power, networking, those types of resources. So here we have availability zone 1, availability zone 2, and availability zone 3, all located within that broader region, which is located within the AWS cloud. Now, we talked a little tiny bit about EC2 instances, but say I had an EC2 instance that I wanted to spin up within this availability zone, and I had one I wanted to spin up in availability zone 2 and availability zone 3. Now, we can also use what are called auto-scaling groups that can span multiple availability zones. And auto-scaling groups can be set up to be triggered that as demand goes up, maybe you have more users logging on, you can get more EC2 instances. You can scale these horizontally. Well, here is a very high-level architectural diagram that I just drew out. If I would have put this up ahead of time and said, all right, let's step through this together, that can be a little bit cumbersome because it's like, hey, what is this A? Why is there a popcorn kernel up here? But starting from the beginning, stepping through together is a way to introduce increasingly more complex topics while making sure your audience is engaged. Another technique that I'll get into in a little bit, but one of the techniques that I used here is that I did what are called on-ramps. And every time I changed color, I took a little bit of a step back. If I was in person, I would have looked around the room, tried to survey the audience, but I reset and I said, all right, we're talking about this auto-scaling group, which is in here, which is in here. And the idea for these on-ramps in your speech or in your lexicon are that if people are maybe a little checked out or not paying attention, it provides them a gentle way to get up to speed. So even if you missed why there's an A here, hopefully you caught what the 1, 2, 3s are or what the EC2 instances mean. So this is an example of a time where whiteboarding, especially with progressive disclosure, can be a really useful technique. All right. I don't know if anyone called in reads a lot of science fiction. I read a lot. And when talking about whiteboarding, this quote by author John Scalzi in one of this trilogy I was rereading over the weekend, but one of the books, The Consuming Fire, great book, check it out. One of the quotes that really stuck out to me is in this space opera book, it was said that the plan is not the goal is the goal. And that is actually a common theme throughout this entire section, but especially with whiteboarding. When you step up to the whiteboard or work with a group to whiteboard out a solution or an architecture, the plan is not the goal. The plan is not to use that time to craft a beautiful and social media worthy whiteboard. The goal is to use that to actually come together and come up with a solution that will meet your needs. I've seen so many times where in whiteboarding environments, people get caught up on making sure it's either beautiful or technically accurate, or if they're maybe too embarrassed about their drawing skills. I mean, I just drew for you guys, so no one should be embarrassed considering what I just shared and how sketch that looks. But I've seen many, many barriers to a conducive whiteboarding session. And I always like to preface it with, we're not here to put together something beautiful on the whiteboard. The whiteboard is a technique to get to the goal. The goal is the goal. It's not about the plan. So I wanted to reiterate one of my favorite quotes in here as well. Again, if you have not read this trilogy, I encourage you to check it out. All right, so additional tips and techniques for whiteboarding. Well, this, again, I was talking about my beautiful whiteboarding skills. This is an image that I wrote talking about AWS Shield, which is a DDoS, a service to mitigate DDoS attacks, Shield Advanced. This is an image of a whiteboarding session I did back in September, trying to figure out how to best organize thoughts and present something talking about the benefits of Shield. Now, I could not tell you what I talked about, what the key takeaways were, but when I was scrolling through my phone to find an example of a whiteboarding picture and this one popped up, it came back like that. I tend to be a very visual learner, but I tend to also relate images very well to a point in time, what was happening, how I was feeling, even what I ate for lunch. I think it's a tip I picked up as a geologist. Back me up, geologist. Remember how when they were first teaching you to fill out your field notebooks, you have to make note of the weather conditions, of how you're feeling, of any other parameters that might impact the experience. Because when you're trying to recreate that and turn your mapping sketches into actual maps, those breadcrumbs can help you piece together a very cohesive experience. Well, that's how I think about whiteboarding. Even if it maybe is a sketch and maybe sloppy, it can be a stake in the road that can help you figure out where you are, figure out some directionality, and take you back to that point in time. So, a few tips on whiteboarding. These are things that I have learned along the way. This is absolutely not an inclusive, all-encompassing list. But the number one technique here really is to think before you ink. I think I first heard that when it came time to tattoos, but I feel like with whiteboarding, it is equally important as well. So let me just clear this out. The main component of thinking before you ink or being more mindful or deliberate, to go into key advantage number 2, is think about how you're going to structure this space. Are you going to structure this whiteboard space in time such that maybe preliminary events take place here on the left, things that happen early, and things that happen later in the journey take place here? For example, in a lot of the whiteboard data flows that I showed earlier, some kind of input would take place here, that data would transform, that would transform, and that would come out there. So is that going to be early and late? Or are you going to use this type of whiteboard as a chance to dive into a user story? Is this going to be told from the point of view of a solution architect Or are you going to start with a user over here? When in doubt, I always love to throw a good stick figure up there, maybe give them a smile because they are an over-delighted customer, and figure out what that input is. Much like the progressive disclosure example I walked through earlier, where I set an overall framework and boundary, I like to start an input and output and just put those up on the whiteboard for a common frame of reference. So for example, dot here, maybe we have a CSV file coming out, and maybe in here we have a .csv file coming off the instrument. Well, what happens in here? Once you have at least the input and output, it reduces the dimensionality of what you're going to cover and can also help to align conversations if people start talking about, oh, well, this thing coming off the machine, and that's not within your explicit boundaries that you set. Another key technique here is practice, and then practice again. And then, you know what, practice a third or fourth time. This is especially true if you are using whiteboarding as a chance to communicate a lot of information in an informal lecture, for example, or if you are at a company and you want to tell your customers what you do. There have been many times where I would have a glossy sales deck behind me talking about whatever the solution was or the product was. And frequently I'd abandon that and just walk up to the whiteboard because I'm much more comfortable drawing things out, taking people together step by step. And that comes from practice. Additionally, start with the goal in mind. Sometimes you walk up to a whiteboard just to communicate information. Sometimes it's a brainstorming session or it's more exploratory. For the sake of your role within the URC family today, we're going to assume that you are going to be whiteboarding in order to communicate information and share best practices. So start with what the goal is. For our sake and example, the goal is going to be communicating how this data should flow through the system. Now, the example we're going to have is I'm going to give you guys 10 minutes, more or less, depending on how we need it to actually go into whiteboarding out the solution. I do want to provide a caveat here, though. This example that the developer shared with us earlier has great symbols, it has great data flow, and in fact, it looks like someone who's an actual solutions architect used actual AWS logos to do this. It looks beautiful and professional. When I whiteboard, I don't typically go with this level of granularity. And for the sake of this, I encourage you to use the level of granularity you feel most comfortable with. If you want to use S3 buckets and solutions, you can do that. If you don't know what these tools are, what these building blocks are, then don't. I mean, for example, if the CSV file, I could just as easily say it's coming into an S3 bucket that is undergoing numerous Lambda functions. It's going back into that S3 bucket, and then it's going into our database, which is serving as an endpoint for our SageMaker notebooks up here. Like, yes, we could absolutely walk through that. However, if you don't know what Lambda is at a level that you feel comfortable using and you aren't familiar with these techniques, whiteboarding doesn't have to be hyper-technical. It can be focused on whatever the language is that your customers are using. So maybe here we say, all right, we have an input file, we have an output file. That then gets checked and it gets validated. So we have some kind of validation of that file. That file then goes into some massive storage. We know it'll be some kind of database. We don't know if it's going to be, again, this should be a database. We don't know if it's going to be RDS. We don't know if it's going to be DynamoDB, but we know that once it's in there, we have to get the data to our data scientists somehow. We have to get the data to ensure that our customers can access it somehow. Does the data scientist take it to the customers? Is it a CSV? If this is the level of granularity that you want to sketch out your solution with, do that. If it is very technical, that is great. And if it's more an idea flow, that is great too. In fact, some of the most effective whiteboarding sessions I've seen have not been anything like that whatsoever. It could be something where maybe I describe what an analytics workflow is. If I'm more focused on building this analytics backend for our customers to see, maybe my whiteboard here is a terminal. or it's a web login, just like our UI UX friends might want. Maybe I make a skeleton right here and I say, here's the username, here's the password. Again, I know this is rough, but that's not the point. The point is maybe I have those URC scores coming right into that backend. Maybe I have great visualization packages coming into that backend. Maybe I have the raw data taken from that S3 bucket coming into the backend. Whatever that looks like, if this is the format and the form factor that you're most comfortable in, that is how you make it your superpower. You play to your advantages and you shake what your mama gave you. All right, so let's go ahead and take 10 minutes to, actually for the sake of time, let's go ahead and take 5 minutes to sketch out something. It can be online with this application, or if you want to go analog, draw something with a pen and paper. We can regroup in the Slack channel after the fact and touch base, maybe compare notes after this session is done. For now, once you draw this, we're actually not going to go too far into the weeds talking about solutions and what the solutions are, because again, the plan is not the goal is the goal here. So go ahead, let's take 5 minutes and let's regroup at 3:11 p.m. CDT.